Good Monday morning or afternoon for 6th period. Today we are covering section 1.6, a library of parent functions, day 1. We will be able to identify and graph linear and squaring functions and identify and graph cubic, square root, and reciprocal functions. But first we need to cover a few definitions, so go ahead and flip to page 2. Okay, we've talked briefly about this before, but a family of graphs is a group of graphs that display one or more similar characteristics. So, for example, the family of quadratic graphs. This is the parent function. Then anything remotely similar to that is part of the family of quadratic functions. As I just said, the parent function or the parent graph is the simplest of the graphs in the family. So it does not contain any plus, minus, dividing, multiplication. It's just a very, very basic function. A couple of things we need to know about linear functions. A linear function has several characteristics. We are typically used to seeing this form, y equals mx plus b. That is the slope-intercept form, but we don't always have to use m and b. This example, f of x equals ax plus b. This is the form your calculator uses where it replaces the m with a. And the y-intercept is b, 0b. Okay, just by knowing 2 points, an entire line can be constructed and the equation for that line can be known. There are multiple forms to write an equation of a line. Again, we talked about the linear form, ax plus b, point slope form, and my favorite, transformational form. This last form is the form we will be using most. Okay, it's very similar to slope-intercept form, only it has moved this over to the right side and it's replaced the x1, y1 with h and k because there's too much going on with all those x's and y's. So it's exactly like the point slope form, only it's moved the y1 over and it's replaced the x1, y1 with h and k. But this is the form we will be using. So if we know f of 2 equals 5 and f of 4 equals 7, we're given two ordered pairs. Okay? Typically we have f of x, so that means that x is 2 and y is 5. And here's our second order pair, 4, 7. Well, if we're going to write the equation of a line in this transformational form, there are several things that we need. The first thing that we need is the slope. The second thing that we need is a point, h and k. The slope is easy to find. Remember, a slope is the change in y's over the change in x's. So everybody take a minute and find the slope of the line that passes through those 2 points. As we can see, the slope of this line is 1. Now, as far as picking the order pair that we want, it doesn't matter. You can pick the first one, you can pick the second one. So that we are all consistent, I'm going to use the first one. I'd like for you all to use the first one. From here on out, though, you can use whichever one you want. So y equals m. Our m is the slope, which is 1. X minus h. Remember, h and k is the same as x and y. So minus 2 plus 5. That's one form. If you chose to use the second order pair, we get y equals 1 times x minus 4 plus 7. It does not matter which one you use. If you simplify, combine like terms, you end up with the same thing. Next, we want to talk about special types of linear functions. The first one is a constant function. A constant function has the form f of x equals c. The domain of a constant function is all real numbers because, as you can see here, our graph continues on forever to the left and to the right, so it is continuous. Domain's all real numbers. The range is just a single number wherever it crosses the y-axis. This one is at 2. So the range would just be 2 for this example. Next, we have an identity function. and it has the form f of x equals x, where your slope is 1, x and y intercept at the origin, and the domain and range are both all real numbers, because as our graph continues on to the left forever and the right forever, it's also continuing to decrease and increase. So it makes the domain all real numbers and the range all real numbers. Next, we have a squaring function. It's in the form f of x equals x squared. Let's talk about the domain. If our graph continues on forever to the left and forever to the right, the domain is going to be all real numbers. Now, the range does not continue down past this line right here. So you can say it's a couple different ways. You can say that the range is from 0 to positive infinity because it does continue to increase. Or you can say it's all non-negative. And we use non-negative instead of positive because non-negative would also include zeros. Whereas if you just said all positive real numbers, that would not include 0. So all non-negative real numbers. Okay, that would be the range. So every y, positive y value falls into our range. Okay, let's talk about the interval on which our graph is increasing. Remember, increasing means that it has a positive slope. So the section of our graph that is increasing starts at 0 and continues on. So we can say that the increasing interval is from 0 to positive infinity. Similarly, the decreasing. Pause me and see if you can figure out the decreasing by itself and the minimum value. So you should say the decreasing is from negative infinity down to 0, and the minimum value is at 0. Now, notice I did not include 0 in any of our endpoints. Okay, at 0, it's equal to 0. It's not increasing or decreasing, so we're using parentheses instead of brackets on the increasing and decreasing intervals. Okay, now let's talk about cubic, square root, and reciprocal. This first one is our cubic. The domain for the cubic, all real numbers. The range for the cubic, all real numbers. The intercept, where does the graph cross the x-axis? Correct, at the origin, 0, 0. Increasing and decreasing. Increasing and decreasing. If you look at this graph, the graph is constantly increasing, so it has a positive slope. So we could say it's increasing on the interval from negative infinity to positive infinity. Okay, next if we look at our reciprocal function, this looks like f of x equals 1 over x. The domain of our reciprocal function, we see that it's going to continue out forever to the left, but look where it stops. Does it ever cross this y-axis? Because it does not, because there's a vertical asymptote there, we cannot include that as part of our domain. So we say the domain is going to be from negative infinity to 0, not including 0, union, and then it's going to pick up right after 0 and go over to positive infinity. I want everybody to pause me and take a minute to figure out the range. The range is just like the domain. Again, it's going to continue on down forever and up forever, but it does not cross the asymptote here at y equals 0. So again, our range is from negative infinity to 0 with a union and then 0 to infinity, but we cannot include the 0 because it does not cross the y-axis. Okay, intercepts. There are no intercepts since it doesn't cross the x-axis. And increasing and decreasing. This graph is increasing. This graph is not increasing anywhere, but it is decreasing from negative infinity down to 0. Our graph is going down, and then also is coming back down again after we go through the 0. So this one does not increase, but it decreases from negative infinity to 0. Again, we're not including the 0. union, and then again from 0 to infinity. So no increasing, just a decrease. Now, I want you to pause me and I want you to do the square root function down here at the bottom. F of x equals square root of x. Find the domain and range, any intercepts if they exist, and increasing and decreasing. Okay, our domain for this one is going to be all real number, or all non-negative real numbers. If you look, we stop here at the origin, so no negative x values are included. So the domain is all non-negative real numbers. The same for the range. The graph, again, stops at the origin, therefore nothing is below the x-axis. So our range is only positive y values, all non-negative real numbers. The intercept, we've talked a couple times, it intercepts here at the origin, so it's 0, 0, and it's increasing from 0 to positive infinity. Here is your homework for section 1.6, day 1. Good luck. Please make sure you notice shape, domain, range, intercepts, increasing and decreasing. If you need to graph, there is plenty of graph paper in the black filing cabinets behind the door. Email me any questions or shoot me a text. Have a good day.